Good morning, grade 10s. Lesson 6, Rational Exponents, Part 2. This is kind of a review of the entire chapter. This is the last chapter in this unit, which means you have a review assignment to be working on and a quiz and test to start preparing for. So if we complete the following, these are basically all the rules that we looked at in this chapter. So the product law. Actually, pause first and try to see if you can fill as many of these in as possible without going back in your notes. So if we look at the product law states if the bases are the same and I'm multiplying them, I can add the exponents. The quotient law says if the bases are the same, I can subtract the exponents. Power of a power law says if I raise a power to another power, it's the same as multiplying the exponents. Product of a power law states that whatever the exponent is outside the brackets will go into both parts inside the brackets. And the quotient, or power of a quotient law, says the same thing. It goes to both parts inside. And then we just have this disclaimer or restriction that says y can't be 0 because I can't divide by 0. The integral exponent rule states that if I have something raised to the power of a negative m, it becomes 1 over x to the positive m. And again, my base can't be equal to 0. Why? Because I can't divide by 0. And the rational exponent law says if I have x to the power of m over n, that can be written as the nth root of x to the power of m, or the nth root of x, which is then raised to the power of m. And we discussed yesterday the fact that this method I would use more so when I'm trying to evaluate. It's much easier to find the nth root of the smaller number and then raise it to the power. So if we write powers as radicals, write each power as radical. This is a review from yesterday. So what I want you to do is pause and then try to go through the 6 questions on your own. So x to the power of 1/6 becomes the 6th root of x. Negative y to the power of 5/4. There's no brackets, so that negative stays outside. Radical symbol, denominator becomes the index of 4 to the power of 5. Negative z to the power of 5/3. That negative goes with the z. So I get negative z. Denominator becomes the index. And then if I want, I can write it as raised to the power of 5 this way, or I can write it as the cubed root of negative z to the power of 5 underneath the radical. Either form would be acceptable. Negative z to the power of negative 5/3 would be the same as this, only it would be written as a 1 over first. That's the only difference between the 2 questions. With E, what we have to be careful of is this 3/4 does not apply to the 5. So the 5 is going to stay outside the radical. The 4 becomes the 4th root of t to the power of 3. Whereas in F, the 5 is part of the 3/4 because of the brackets. So this becomes the 4th root of 5t to the power of 3. Question number 2 combines some of the power laws with the fact that we have rational numbers. So if I look at 2a, I have x to the power of 3 halves times x. The rule states I add the exponents. So the exponent on this is a 1. So if I take 3 halves and I have to add it to 1, I have to go back to my rules for adding fractions. Fractions can be added only if the denominators are the same. I need common denominators. So if I want to change 1 into halves, how many halves are there in one whole? 2 halves. So 3 halves plus 2 halves gives me 5 halves. That's the positive exponent. Now if I write it as a radical, there's my radical symbol, x. The 2 would become the index, which means it's not necessary, and the 5 becomes the exponent. If we look at b, the quotient law says subtract the exponents. So 1/3 minus 5/3 would become negative 4/3. So then when I go to write this with a positive exponent, it would become 1 over y to the power of 4/3. As an entire radical, this becomes the cubed root of y to the power of 4. So the cubed root of y to the power of 4 all over 1. With c, I'm raising a power by a power, which says I multiply the exponents. So when I go to multiply these exponents, I multiply straight across. 1 times 2 is 2. 2 times 3 is 6. So I get 2 over 6, which I can simplify to be 1/3. As a radical, it's the cubed root of a. With d, I have a negative exponent. So to make that negative exponent positive, I'm going to flip. And then now my exponent becomes positive. Remembering again, my exponent does not flip, just the base. So as an entire radical, I get the square root of, if I continue on, I will get y to the power of 1/2 over x to the square times 1/2. When I multiply 2 by 1/2, I get 1 for an answer. So I just get x. So what I would end up with as a radical, y to the power of 1/2 as a radical becomes the square root of y. X is not written as a radical. So now let's take a look at class example number 3. Simplify the entire radical. Write each has a power with a positive exponent and as an entire radical. So we have to combine. We have coefficients, so I multiply my coefficients. 4 times 3 is 12. Then product says I add the exponents. So I have 3/4 plus negative 1/2. Well, negative 1/2 has to have the same denominator. We need this common denominator. Common denominator for 4 and 2 is 4. So my negative 1/2 would become negative 2/4. 3/4 plus negative 2/4 is 1/4. So I get 12 times x to the power of 1/4. As a radical, that 12 would stay outside the radical symbol. The denominator becomes the index. So I get the 4th root of x. If I look at b, I have 5 and 25. When I go to reduce this, I'm going to put it down here. And I have to reduce it this time because I can't take this number and divide by 25. I get a decimal. But I can reduce it by dividing both the 5 and the 25 by 5, which will give me a 1 and a 5. And then according to my exponent rules, I'm dividing, so I subtract the exponents. 3/5 minus negative 3/5 is 6/5. So I get x to the power of 6/5 over 5. I don't need that 1 now. As a radical, this becomes the 5th root of x to the power of 6 all over 5. Or I could write it as 1/5 times the 5th root of x to the power of 6. And with C, we've got brackets in here, so the 4/3 will come to the 8. So I'll have 8 to the power of 4/3. And then A, multiply the exponents. So 1/2 times 4/3 becomes 4/6. If I go and I simplify these, this 8 to the power of 4/3, that's the same as the cubed root of 8 raised to the power of 4. Cubed root of 8 is 2. 2 to the power of 4 becomes 16. So I get 16. My 4/6 becomes 2/3, which now as a radical is the cubed root of A squared. So what I would like you to do right now for about the next 10 or so minutes is practice these questions. 1ADF GHI, 6ACFH, or sorry, not 6, that should be 2. 2ACFH, and 3ACFH. Give yourself about 10 minutes and then you can start the next part of this lesson. So the last part of this lesson looks at actually going backwards. Most of the stuff that we've done to this point is we've taken a power and we've written it as a radical. But what if we went backwards and we took radicals and wrote them as powers? So just to review, if I have a radical and I want to write it as a power, my base is still going to be the same. Remember, my index was always the denominator, and then this exponent will become the numerator. So with that said, try to see if you can do the next 3 on your own. Pause, and then play. So the 5th root of A squared would become A to the power of 2/5. With C, the trick to remember is if there's no index, it's actually the number 2. So this would become A to the power of 9/2. And finally with D, again, the index would be 2, and I'd have 1 over A to the power of 7/2. So question number 5, write as a power and calculate. So if I write this as a power, I have 2 radical symbols here. So we're going to work from the inside out. So this first radical symbol right here, as a power, becomes 1296 to the power of 1/2. This radical symbol here is also a square root, so it would be to another 1/2. 1/2 to the power of 1/2, multiply the exponents. 1/2 times 1/2 is 1/4. So if I was to put this into my calculator, it would be 1296, so 1296 to the power of, and then I'm going to use brackets, 1 divided by 4, and then press enter. And when I do that, my answer becomes 6. Question number 1, B, not B, question letter B. 1 over the square root of 169 becomes 1 over 169 to the power of 1/2. 169 to the power of 1/2 is 13, so I get 1 over 13. With C, I'm writing this as a power, remember, so this becomes the square root of 64, which as a power is 64 to the power of 1/2. 1/3 as a power, cubed root as a power is 1/3. So I will get 64 to the power of 1/2 raised to the power of 1/3, which would become 64 to the power of 1/6, which would equal 2. Question number 6, we are dealing with coefficients as well as variables. So the best way to do these is to actually separate them out. So with A, I have the cubed root of 8x to the power of 5. So this is the cubed root of 8 times the cubed root of x to the power of 5. So if I was to simplify this, this is in the form with a rational exponent. So the cubed root of 8 I would evaluate and I would get 2. The cubed root of x to the power of 5 I would now write as a rational power and I would get 5/3. So if you want, try pausing and try working on the next 4 questions before you play so that you can see as we go through them one at a time how you're doing. So if I look at B, I have the 5th root of 32 times the 5th root of x cubed. The 5th root of 32 is 2, and x cubed to the power, or the 5th root of x cubed becomes x to the power of 3/5. For C, I have the square root of 900 times the square root of x. The square root of 900 is 30, and the square root of x becomes x to the power of 1/2. With D, change both of these to powers, and I get x to the power of 5/3 times x to the power of 1/3. My exponent law tells me to add the exponents. 5/3 and 1/3 is 6/3, which is 2. So I get x squared. With E, again, change these radicals to power. The square root of x becomes x to the power of 1/2. The cubed root is x to the power of 1/3. When I go to add these together, because that's what I'm supposed to do to the exponents, I need a common power, or a common denominator, which would be 6. 1/2 is 3/6. 1/3 is 2/6. Together, that would give me 5/6. So 3 more examples, and then I'll give you more questions to work on, and that will be the end of this lesson. Question number 7 says, write an equivalent expression using exponents. So again, when you have these double radicals, work from the inside out. So if I work with this first one, I'm going to get the square root of a to the power of 3/2, because this was an index of 2. That is going to become a to the power of 3/2 raised to the power of this radical is 1/2. Multiply the radicals together, and I get 3/4. So again, if you want, you can try to see if you can do these on your own first. So if I look at B, inside here we have the cubed root of 64, and then we have V. So if I write this out, I have the cubed root of 64, and then I have V to the power of 6/3. So the cubed root of 64 is 4. And then I've got V squared, 6 divided by 3. This now all gets to the power of, or to the square root. So the square root of 4 times the square root of V squared. Square root of 4 is 2. As a power, this becomes 2/2. The index was 2. 2/2 is 1. So I get 2V. And this goes back to that idea that the square and the square root cancel each other out. They're inverse operations. It's like adding and subtracting by the same number or multiplying and dividing by the same number. It doesn't change anything. It cancels out. And finally with C, This bracket, if I look at it first, becomes x to the power of 5, y to the power of 3, x to the power of 5 quarters, and y to the power of 3 quarters, because that denominator would go to both parts inside the radical, and that would be raised to the power of 3 halves. So then I'm going to multiply these exponents together. 5 quarters times 3 halves becomes 15 eighths. And 3 quarters times 3 halves becomes 9 eighths. So to add to the previous questions, we have 4AD, 5A, 6AF, 7ACE, and then 8 to 16. That's actually the conclusion of the chapter, so our next class we will be looking at chapter 3.